At the core of one branch of calculus is something called a difference quotient. And a difference quotient is really essentially a slope. So let's consider a slope between 2 points. The slope between x2, y2 and x1, y1 is m equals, well, it's rise over run. So y2 minus y1 divided by x2 minus x1. And now here we have a generic graph that gives the line between the 2 points x1, y1 and x2, y2. Suppose we relabel things and I say instead of x1 or x1, I'm going to call x1 A, and then I'm going to call x2 B. And then we're going to consider the line between A and B. I guess if it's a line, I should have arrows. It's going to be the graph of the function f. Therefore, the output that we're calling y1 is f of a, and the output that we're calling y2 is f of b. With these labels, the point x1, y1 now becomes a f of a, and the point x2, y2 becomes b f of b. And we can therefore express the slope between these 2 points using function notation as f of b minus f of a divided by b minus a. This is one of the difference quotients. There are differences in the numerator and denominator, and it's a quotient. You may recall this from pre-calculus as the average rate of change. Formally, it would be the average rate of change of f as x goes from a to b. We are now going to refer to this as a difference quotient. Okay, now I'm going to go back to the graph here. I'm going to keep the label x1 equals a. But now I want to consider the second point, which right now is x2, y2, also given by b, f of b. I want to think of it now as a movable point. I want to be able to move it left and right. I'm not actually going to move it, but in order to think about how this can move, instead of labeling x2 equals b or anything like that, what I'm going to do is I'm going to refer to a distance from the point where x1 is equal to a. And so I'm going to identify that the distance between a and b on the x-axis, I'm going to call that h. Therefore, x2 now has the expression a plus h. And I can let h equal 1/2 or 1/10 or 1/4, and that would give me a different second x coordinate for the point that's on this line, you see. If my x coordinate for the second point is a plus h, then my y coordinate is f at a plus h. And again, it's just another label for the same point, but you see I can now move the second point just by varying h. But now we can consider the average rate of change and say m is equal to f of a plus h minus f of a divided by a plus h minus a. Right, so it's f of a plus h minus f of a divided by a plus h minus a. This thing simplifies, at least in the denominator. And I have f of a plus h minus f of a divided by simply h because the a's subtract out. This is another difference quotient. So now I'll draw arrows saying we have these two difference quotients. And the difference between these difference quotients here, they both depend on where a is. But in the first case, we needed to know what the point was for b, right? b f of b. And here we can just say, well, it's a and then plus some distance h. And as long as I know what h is, I'm able to crank out a difference quotient. The reason we care about that, without getting into too much detail, is down the road, we're going to want to be able to make h really small. But we're going to put that on a shelf for now. And we're just going to see how we can manipulate a difference quotient. And that's what we'll do in the next video.